In this video, we will explain how to use the command Create Mesh Solid Block Points by Point Cloud to create 3D mesh in VEGA. This command allows you to perform many interesting tasks, such as creating a 3D surface network, DTM, triangular irregular network. You can use this command for removing unnecessary elements, for example trees, cars, poles. You can use it for creating 3D solids that can be exported to other programs to check the flatness of surfaces such as walls and floors. Today, we will demonstrate how to create triangular irregular network using the surface of a desert canyon. Its other features are explained in the corresponding videos. Select the point cloud and configure parameters. Surfaces can be created either by the world coordinate system, which is convenient when we create the surface of the ground, or by the user coordinate system. Creating a surface with a user coordinate system gives us the possibility to draw the surface with negative angles or overhanging surfaces. Object type, 3D mesh, solid, point, block, contour lines, etc. There is a separate command for creating contour lines, but they can also be created using this command. Creating contour lines with this command is convenient when you need to automatically filter trees, poles, cars, and so on at the same time. In this case, we are interested in a mesh consisting of 3D faces. The next parameter to define is the side from which the point cloud will be viewed, top or bottom. The choice of this parameter depends on which side of the point cloud we have the most noise points. As a rule, when creating the ground surface, it is convenient to view the cloud from the bottom. There is much less noise on the bottom side than on the top side. However, there are cases when it is better to consider the surface from the outside. Approximation of places where there are no points on the point cloud. In this case, VEGA can either triangulate using the closest points to the holes or make an approximation. We specify that the mesh vertices should be located at the points that make up the point cloud. These parameters are very important parameters for creating triangular irregular network. The VEGA program uses the Delaunay triangulation algorithm to create the triangular irregular network. Now specify the dimensions of grid cell, 8 meters. Tolerance to find points on the surface of the ground. In this case, it is enough to set 10% of the distance between the points. In cases when there is automatic filtering of objects during network creation, this parameter will be different, but we will tell you about it in the video dedicated to automatic filtering of objects. In this point cloud, the distance between its points is about 0.2. Let's see what that is, and then go back to the parameters. The distance between its points is about 0.2. There is no reason to make it less than 0.2, because the points just won't be found. Let's go back to our command. Here we have not changed anything. The distance between the points is 8, which is the maximum on flat surfaces. Tolerance of 0.8. These two parameters are very important for the accurate creation of an irregular network. If the parameters are not set, the program will divide the surface into triangles with a distance of about 8, and we will get the surface of the ground, which will not accurately show the places of changes in the slope of the surface. If we set the value, for example, 0.2, we will get an accurate surface of the ground. But at the same time, we will get a large number of triangles, which will be inconvenient to work with. However, if we set these two parameters, we will get both an accurate model of the ground surface and an optimized number of triangles. If the surface has a small slope, the distance between the points will be large, and if the slope is large, the distance between the points will decrease. This will give us the possibility of not creating and using break lines, which first of all requires a lot of extra work, and secondly, which is very important, does not give the accuracy that we get when using this command of the VEGA program. The first parameter defines the slope, after which the division of large triangles into smaller ones will begin. The second parameter defines the minimum side of the triangle. Let's set the slope value greater than 6 degrees and the minimum side of the triangle to 0.25. This means that when the VEGA program detects a triangle with a slope in 6 degrees, it will start to divide it and continue until either all the triangles are created with a smaller slope or the side of the triangle reaches the minimum value. In our case, 0.25. This point cloud represents the desert surface. So for flat surfaces, we need distance 8, and for slopes, we need distance 0.25. The distance 0.25 is the size of a small stone. These parameters are intended for automatic filtering of objects that are unnecessary for TIN. These can be cars, trees, poles, metal structures, and the like. We will consider the use of these parameters in the video dedicated to automatic filtering. Rounding parameters. VEGA works with zero error. That is, the coordinates of triangles are taken from the coordinates of points in the point cloud. By default, the value is not rounded, but if necessary, it can be rounded. The last parameters are used to create a text file with the coordinates of the points when the command is finished. There is a separate command for exporting points, but you can export them right here. This feature is disabled by default. I remind you, the use of parameters for automatic filtering will be considered in a separate video. Let's see how this command works. Selection methods. Window. 2 points are defined, which specify the rectangular area in which the irregular network will be created. Border. Free selection of points defining a free-form polygon. Polyline. Selection of an existing closed polyline that will be the boundary of the calculated region. Selection methods. Border. VEGA checks the surface condition, finds the necessary set of points, calculates points on corners, checks them on the ground surface, finds the corresponding points from point cloud. We have a triangular irregular network consisting of 3D faces objects. Let's look at our surface from the side. Let's change the transparency. We can do different things with the resulting surface. We can color it depending on either the slope angle or the height. The coloring based on the ground surface will be shown in another video. For now, we will see how it will look depending on the slope. Let's set a world coordinate system. Color map type. Let's choose scale color, that is, different colors. The number of layers on which the 3D faces will be distributed depending on the slope angle. Let's set it to 30. We have 3D faces distributed on different layers. Let's close the layer. What we see is that VEGA has distributed all the 3D faces to their corresponding layers according to the different angles, and we can turn them on or off. In addition to creating layers, a layer filter has been created that can only be manipulated by these layers created by the command. If we now look at our surface from above, we can see the slope boundary very clearly. Where the surface is smooth, the dimensions of the triangles are large. Where there is a slope, the dimensions of the triangles are smaller. For example, at this point, the distance from the top to the opposite side of the triangle is 0.07. I remind you that the maximum distance between points on flat surfaces is set to 8. This unique ability of the VEGA program to create triangles depending on the angle of inclination of the surface saves us from long manual work of drawing break lines. This mesh can be exported to Civil 3D or Revit for further use in those programs. Or you can use it to create contour lines. The process of creating contour lines using the VEGA program will be discussed in a separate video. I want to focus your attention on another interesting aspect. Let's look at this node of the mesh where several triangles converge. We will erase the triangles that converge on this node one by one. Note the point where the mesh node is located. I erased the last triangle, and we can see that its vertex was exactly on one of the points of the point cloud. When we set the parameters, we specified that the mesh vertices should be located at the points that make up the point cloud. This means that the accuracy with which the VEGA program works is absolute and equal to 0, and a result of this command, you will get points that depend only on the accuracy of your point cloud. We can color not only by angle, but also by height. The principle is exactly the same. The same way we choose the scale color, we define the zero plane. Look what we have. The minimum height is red. The maximum height is blue. And in the same way, we can turn layers on and off. This accuracy is not always a good thing, because it gives you quite sharp edges, which is not very good for modeling. Let's turn off our point cloud again. Let's say realistically, we see some hard edges here, here, and here. Sometimes we need to smooth out those surfaces when we're modeling and creating a three-dimensional solid for use in Revit. There's another tool for that. Let's copy our object. Create mesh solid block points by objects. This is also a very powerful tool and will have its own video. We will talk about this tool separately. But for now, I just want to show you one of its features. I'm going to select this surface. We are only interested in one parameter, which we are going to change. The other parameters will be discussed in other videos. The more iterations we choose to do, the more triangles we will get. Let's look at this surface from the 3D modeling when we want a smoother, nicer result. We're going to color it exactly the same as the unsmoothed one in height. You can see how much smoother and nicer the image has become. Let's see what it looks like if we color it based on angle. We can convert generated meshes into 3D solids, civil surfaces, or points text files. Let's create points text file. The object can be anything. It can be a point, it can be a polyline, it can be a block, it can be a 3D face. We select our mesh, set the precision for the coordinates, and select these objects. Save file. Now we will look at the possibility of creating networks using a closed polyline as a boundary. Drawing a closed polyline. The convenience of using closed polylines is that, first, you can always return to the boundaries accurately. Second, you can use arcs as boundaries. Let's draw an arc. We define the polyline to be closed. Without changing any parameters, we select the polyline. Select our closed polyline. Erase the point cloud. Erase the polyline. We've got a surface with one of its boundaries being an arc. This triangular irregular network was done using the Create Mesh Solid Block command. I will show you the result of this command, which includes automatic filtering of objects unnecessary for tin. We will talk about how to do this filtering in detail in the videos dedicated to these processes. The result of these filtering processes will be surfaces or contour lines that are free of unwanted objects. These can be cars, trees, poles, metal structures, and so on. There is no need to pre-clean the point cloud from these objects.